Okay, so in this video we're going to look at definite integration. Definite integration, we have bounds of our integration. We have our lower bound here, which is 1, and our upper bound, which is 3. Excuse my writing. And we're integrating, this is our integration symbol here. It just means we're going to integrate. We've got a function x squared which we're integrating, and we're integrating that function with respect to x. And what we actually get when we integrate this function between 1 and 3 with respect to x is the area bounded by the curve y equals x squared and the x-axis between the values of x equals 1 and x equals 3. So integrating this function will give us a numerical value. So what we do when we integrate definitely is we're going to integrate the function like we did when we integrate indefinitely, but we're not going to need the plus c, the constant of integration now. So if you integrate x squared with respect to x, you add 1 to the power, so it becomes x cubed, and you divide by the new power. So we get a third x cubed. We write this in square brackets, and we write our bounds on the right hand side. So now what we're going to do is we're going to evaluate this function at these two bounds, 3 and 1. We're first going to evaluate it at our upper bound. So it's going to be a third times 3 cubed, and we're going to subtract the value of our integral at the lower bound, a third times 1 cubed. So 3 cubed is 27, so we have 27 over 3 minus 1 cubed is 1, so we've got 1 over 3, which gives us 26 over 3. So what this tells us is that our area here is equal to 26 over 3 units squared. Okay, so now we're going to look at what happens when we integrate the cubic function x times x minus 1 times x plus 1 with respect to x between minus 1 and 1. And what we should be hoping to get is this area that is shaded here. So we've got an area above the x-axis and an area below the x-axis. So if we do this, we need to expand this out. We get the integral of, let's expand these brackets out, it's a difference of 2 squareds. We get x squared minus 1, and expanding this out a bit more, we get x cubed minus x. This is what we need to integrate. So if we integrate x cubed minus x, we get a quarter x to the power 4 minus a half x squared. And our bounds are -1 and 1. So we're going to evaluate this at 1. And we're going to subtract the value of this at -1. So that's -1 squared. So in this bracket here, we've got a quarter times 1 to the power 4. 1 to the power 4 is 1, so we've got a quarter minus a half times 1 squared. That's minus a half. And in this bracket here, we've got minus 1 to the power 4, so we've got a quarter minus a half. That's clear, we've got a quarter minus a half here. That's the same as a quarter minus 2 quarters, so that's -1 quarter. And we've got a quarter minus a half here. That's also -1 quarter. So we actually end up with this equaling 0. Now clearly this area here is not equal to 0. Due to the symmetry of this graph, we know that this area between -1 and 0 is actually the same as this area between 0 and 1. So what we've actually done here is cancel these areas out. Right, so this is an important result. When we've got an area such as this, which is bounded between the curve when it is negative and the x-axis, so it's the area under the x-axis. If we integrate between 0 and 1, we're going to get a negative value for that area. And this is because of the way integration works. So what's happened here is we've got a positive area here and a negative area, and they've cancelled each other out. So what we need to do to find this area is to do the integral between -1 and 0 of x minus 1, x plus 1 dx, and we need to add the negative integral between 0 and 1 of x minus 1, x plus 1 dx. And the reason why we've made this negative here is because we're going to get a negative value for this area that is underneath the x-axis. So if we do this quickly, this is going to be a quarter x cubed x to the power 4 minus a half x squared between -1 and 0, and we've got to subtract a quarter x to the power 4 minus a half x squared between 0 and 1. So this expression gives us our area, and if we evaluate that, we will find the area under the curve. A final example is where we've got an area that is bounded by a line and a curve. So we're not just finding the area under the curve here. Now what we can do is we can split this up into areas that we can find. This blue area here is the area under the line y equals x plus 1. And we need to find out our coordinates here, where this line that's perpendicular to the x-axis crosses the x-axis. So what we need to do is find out where this line and this curve intersect. So to do that, we've got to solve the equation x minus 2 squared plus 1 equals x plus 1. So expanding out this left-hand side, we've got x squared minus 4x plus 4 plus 1 equals x plus 1. And tidying this up, we've got x squared minus 5x plus 4 equals 0. So when we factorize this, we're going to have x minus 1, x minus 4 equals 0. So we can see that the x coordinates of where these two the curve and the line intersect are x equals 1 and x equals 4. So we can mark this on the graph. Okay, so now we can actually find this blue area here, which you should recognize as a trapezium, by finding the area of this trapezium. You can use the formula. An alternative way to do it is to say it's the integral, the area under the line, x plus 1, the integral of x plus 1 between 1 and 4 with respect to x. So we can find that blue area. Now we can also find the area under the curve. The area under the curve between 1 and 4 is this red area that I've shaded here. So to find the area shaded in black, we can say that it's going to be the area shaded in blue. Let's call that A1. Take away the area shaded in red. Let's call that A2. And we know the area shaded in red, A2, is going to be the integral of the curve, x minus 2 squared plus 1, with respect to x, between 1 and 4. So now what we can do, we can actually come up with an expression for this area. We can say that the black shaded area we want to find is the integral between 1 and 4 of x plus 1 with respect to x, minus the integral between 1 and 4 of x minus 2 squared plus 1 with respect to x. So now, by evaluating these two definite integrals, we can find the shaded area that we were asked for.